Hello everyone, welcome to my YouTube channel ECE Scholastic. I am Jasmine. So today we are going to start our session 10 under Control System series. So in this session we are going to start a new topic called electrical analogy. In this session we are going to see what is an electrical analogy, what is the relation between mechanical and electrical systems, what are the formulas used and what are the steps involved to solve the problems. Okay. So we know that this mechanical and electrical systems are the broad classification of mathematical models of control systems, right? So till session 9 we have discussed the basic concepts, ideologies, the steps and formulas used under mechanical, translational and rotational system for solving problems. So from this session we will be focusing on electrical analogy, okay? So let's start our session. Let's discuss what is electrical analogy. So electrical analogy is a method used for analyzing the mechanical, translational and rotational system and converts them to an electrical system. Okay. As we know, the basic elements of mechanical translational system is mass, dashpot and spring. Similarly, for mechanical rotational system, it is moment of inertia, dashpot and torsional spring. Correct? And the basic elements of electrical system is resistor, inductor and capacitor. Correct? So, electrical analogy method is used to convert the mechanical system to an electrical system by replacing the elements. Okay, which means we are going to replace this mass or moment of inertia, dashpot and spring in terms of resistor, inductor and capacitor for analysis purpose. Okay, as we know, the output of mechanical systems is a differential equation, whereas the output of electrical system is an algebraic equation. Okay. For converting the translational system to an electrical system, we are following two procedures, that is force voltage and force current. Similarly, for rotational system, we are having two procedures, that is torque voltage and torque current. Let's see all these in detail. Let's see what is the relation between electrical and mechanical translational system first. Mechanical translational system, the input is force and the output is velocity. And the basic elements are dashpot, mass and spring. Okay. For force voltage, the input is voltage and output is current. Similarly, for force current, it is straight reverse of force voltage. That is, input is current and output is voltage. Okay. And for force voltage, the dashpot is replaced by resistor, mass is replaced by inductor and spring is replaced by capacitor. Similarly, for force current, dashpot is replaced by resistor, mass is replaced by capacitor and spring is replaced by inductor. So the only change is here mass is replaced by inductor and here it is capacitor. Here spring is replaced by capacitor and here it is inductor, just the reverse. Okay, whereas the resistor is used for replacing the dashpot in force voltage and force current. Okay, and the formula used for analysis of force voltage is Kirchhoff's voltage law. Okay, since we are using Kirchhoff's voltage law, we will be writing the voltage formula for all the three electrical components. That is, for resistor, the voltage formula is V is equal to IR, and for inductor, the voltage formula is V is equal to L into di by dt, and for capacitor, the voltage formula is V equal to 1 by C into integral of I dt. So hope you understood why we have written here 1 by C, because in the formula it is 1 by C. Okay. Similarly, for force current, we will be using Kirchhoff's current law. Okay. So we will be writing the current formula for the electrical components. So the current formula for resistor is I is equal to V by R. For capacitor, I is equal to C into dV by dt. And for inductor, I is equal to 1 by L into integral V dt. Okay. Now you might have understood why we have written here 1 by R. Here the formula is 1 by R. And here the inductor is written as 1 by L. The formula we are having 1 by L. Understood? Please learn all these voltage and current formulas, which is very necessary to solve the problem. Next, let's see the relation between electrical and mechanical rotational system. So for mechanical rotational system, the input is torque and the output is angular velocity. Okay. Here the basic elements are dashpot, moment of inertia and torsional spring. Here we have two methodologies, that is torque voltage and torque current. So for torque voltage, the input is voltage and the output is current. And similarly for torque current, which is straight reverse to torque voltage, that is input is current and output is voltage. All the other replacements, that is for dashpot we are using resistor, and for moment of inertia we are using inductor, and for torsional spring we are using capacitor. Similarly for torque current, the resistor is same, but for moment of inertia we are using capacitor, and torsional spring we are using inductor. All the other things are the same. Okay, and here also we will be using Kirchhoff's voltage law for torque voltage, and the same formula pattern we follow. And for current formula we will be applying Kirchhoff's current law, and the same pattern is followed. We will be using the current formulas. Okay, the only variation is there we are using force and here we are using torque. There we are using velocity and here we are using angular velocity. Okay. Next is, let's see the electrical analogy for mechanical translational system. So that is, here we have two analysis, force voltage and force current. So for force voltage, V is replaced as R resistor, and M is replaced as L inductor, and K is replaced as capacitor. Okay, this is for force voltage. And for force current, B is replaced as 1 by R resistor, and M is replaced as capacitor, and K is replaced as inductor. We will see electrical analogy for mechanical rotational system. Here also we are having two analysis. One is torque voltage and the other one is torque current, right? So for torque voltage, B is replaced using resistor, J is replaced using inductor, and spring is replaced using capacitor. And for torque current, B is replaced using 1 by R, J is replaced using capacitor, and K is replaced using inductor. If you analyze these two, force voltage and torque voltage follows the same concept. See, BMK, see here it is BJK, RLC, and here it is RLC. Okay, and for force current, torque current, both are same, both assumptions are same. That is BMK RCL and BJK RCL. Understood? Okay, so let's move on to the steps. So the first step is we need to determine the differential equation for the given system, which is same as that of finding differential equation under mechanical translational and rotational system. We will be using force balancing and torque balancing equations. Okay, same concept till finding differential equation. And next is we need to replace linear displacements in terms of linear velocity. So here I have mentioned the input as velocity, right? Assumption comes here. Okay, that is linear displacement is replaced as velocity. Okay, so instead of x, we will be writing integral v dt. Okay, instead of dx by dt, we will be writing v. And instead of d square x by dt square, we will be writing dv by dt. So let me consider an example, that is, if I am having an expression that is m into d square x by dt square. So I will be replacing this as m into, what is d square x by dt square? So d square x by dt square is replaced as dv by dt. So I will be writing this as dv by dt. So I am changing the expression in terms of linear displacement to expression in terms of linear velocity. Okay. So similarly, if I am having an expression like this, b into dx by dt, I will be replacing this as b into, what is dx by dt? Dx by dt is velocity v. So that is b into v. Okay. So if I am having an expression like this, kx, so kx I can replace this as k into, what is x? X is integral v dt. So integral of v dt. Okay. So I'm going to replace the displacement equations in terms of velocity equations. Since we know the basic expression for velocity is equal to rate of change of displacement and acceleration is equal to rate of change of velocity. Okay, this is for mechanical translational system. Okay, that is the important note. And for mechanical rotational system, we will be replacing the angular displacement. What is our angular displacement? Theta is our angular displacement. So we are replacing angular displacement in terms of angular velocity omega. Okay. So how the expression will change? Instead of m, we will be writing j. So j into d square theta by dt square is replaced as j into what is d square theta by dt in terms of angular velocity? D omega by dt, and also b into d theta by dt can be written as b into omega. Okay, and k into theta can be written as k into integral of omega dt. Understood? So this is for mechanical rotational system. So we will apply all these replacements and will rewrite the differential equation in terms of velocity for MTS and in terms of angular velocity for mechanical rotational system. Is that clear? Okay. So the next step is we will redraw the mechanical system. Okay. We will redraw the mechanical system to one electrical system by replacing all the mechanical elements with the help of this electrical elements, which means that for force voltage, the BMK is replaced by RLC, and for force current, the BMK is replaced by RCL. This is for mechanical translational system. And for mechanical rotational system, we have torque voltage and torque current. So for torque voltage, BJK is replaced by RLC, and for torque current, BJK is replaced by RCL. Understood? So we will be replacing all the mechanical components in terms of electrical components and will redraw the mechanical system into an electrical system. Okay. So our final step is we will apply Kirchhoff's voltage law and Kirchhoff's current law to the electrical circuit to obtain mesh analysis and nodal analysis equations. So we will apply Kirchhoff's voltage law for mesh analysis. Okay. And Kirchhoff's current law for nodal analysis. So the output of voltage, that is force voltage and torque voltage, the output will be mesh equation, and the output of force current and torque current will be the nodal equations. Understood? So that's all about the steps. So thank you for the patience and thank you for the interest you are showing in all these tutorials. If you have any queries, please mail me. Don't forget to like, share and subscribe. Thank you. Have a great day.